Hello student. Now we learn a Lenz law of electromagnetic induction. So in previous video we learned Faraday's laws of electromagnetic induction. Faraday's first law gives us cause of induced EMF. Second law gives us magnitude of induced EMF. But both the laws unable to give us direction of induced EMF. The direction of the induced EMF is given by the Lenz law of electromagnetic induction. Now let's see the statement of the Lenz law. The statement is the direction of induced EMF. The direction of induced EMF is such that which opposes change in magnetic flux. Change in magnetic flux. So this is the statement. Now, how this statement gives us the direction? Let I explain it. So direction of induced EMF is such that which opposes change in magnetic flux. Now let I explain this. So explanation. So for that we consider a coil. So I consider only one turn of the coil. So this is a coil. So when we bring this bar magnet having N pole towards this coil, then what happens? The magnetic flux associated with the coil increases. Magnetic flux increases. Then to oppose this increase in magnetic flux, because here the direction of induced EMF is such that which opposes the change in magnetic flux. So here, as we move the magnet towards the coil, the magnetic flux associated with this coil increases. And to oppose this increase in magnetic flux, we have means here N pole is produced on the face of the coil, and you know that N repulsion force is there. So here this increase in the magnetic flux is opposed. So as you know that when the N pole is produced on the face of the coil, the direction is anti-clockwise direction. So therefore the direction of induced EMF is in anti-clockwise direction. So this is the case 1. Now in case 2, if I consider instead of this N pole moving towards the coil, we have to move this N pole away from the coil, or I will explain it here only. So if this N pole is moved away from this coil, then what happens? The magnetic flux associated with the coil decreases. Magnetic flux decreases. Then to oppose this decrease in magnetic flux, so here S pole is produced on the face of the coil. Then only this decrease in the magnetic flux is opposed. As S pole is produced on the face of the coil, it means that direction is in clockwise direction. Means here the direction of induced EMF is in clockwise direction. So therefore here we learn this Lenz law. I hope everyone understood the meaning of this statement. So direction of induced EMF is such that which opposes the change in magnetic flux.